Welcome back. In this video, we are going to solve a structural design problem that involves a simple beam design using load and resistance factor design method based on eStructural Design Tao found on the App Store. Design a reinforced concrete beam using load and resistance factor design with one end continuous span of 30 feet, assumed size of 15 inches by 30 inches. The beam carries two concentrated loads, each with dead load of 25,000 pounds and live load of 20,000 pounds, that divides the whole span into three equal segments. Design criteria as follows: strength of concrete 6,000 psi, main bars 1 inch diameter grade 60, stirrup bars 3/8 inch diameter grade 60. The beam carries two concentrated loads, each with dead load of 25,000 pounds and live load of 20,000 pounds, that divides the whole span into three equal segments. The beam self-weight is 469 pounds per foot for a factored uniform load of 562.8 pounds per foot. Enumerate input parameters required. Name of beam B11, type of support one end continuous, width of beam 15 inches, depth of beam 30 inches, length of beam 30 feet, main bars 1 inch diameter at grade 60, stirrup bars 3/8 inch diameter at grade 60, strength of concrete 6,000 psi, factored uniform load is 562.8 pounds per foot, and total factored concentrated load is 124,000 pounds. Given factored uniform load equals 562.8 pounds per foot, each factored concentrated load equals 62,000 pounds, L equals 30 feet, the maximum moment from uniform load is 607,824 inch-pounds. The maximum moment from concentrated load is 7,440,000 inch-pounds, for a total maximum design moment of 8,047,824 inch-pounds. The rho max from the given design criteria is 0.0283, then the maximum concrete beam design ratio Rn max equals 1,414.48 psi, followed by maximum moment from given section Mu max equals 14,440,956.75 inch-pounds, which is greater than the maximum design moment Mu. Given maximum moment equals 8,047,824 inch-pounds, resistance factor equals 0.9, B equals 15 inches, and D equals 27.5 inches, the beam design ratio Rn equals 788.28 psi, and reinforcement ratio Rho equals 0.01435. Given Rho equals 0.01435, B equals 15 inches, and D equals 27.5 inches, the area of steel for tension bars is 5.91937 square inches, and the number of bars for 1 inch diameter is 8. The number of compression bars is 2. The shear force for dead load is 32,035 pounds, and live load is 20,000 pounds, for a maximum shear force of 70,442 pounds. The nominal shear force is 93,922.67 pounds, greater than 63,904.23 pounds concrete capacity. The shear force capacity of stirrup is 30,018.44 pounds, less than 255,616.9 pounds maximum stirrup capacity. Maximum spacing is 10 inches. The shear force at face of support is 22,513.83 pounds, and initial spacing at 16.12 inches. The stirrup spacing are as follows: 1 at 2 inches, 1 at 4 inches, 1 at 6 inches, rest at 10 inches. For 1 inch diameter main bars, use half-inch diameter stiffener bars. Design recommendation as follows: FC prime equals 6,000 psi, Fy equals 60,000 psi, beam size is 15 inches by 30 inches by 30 feet, main bars of grade 60, At support, top bars 8 pieces 1 inch diameter bar, stiffener bars 2 pieces half inch diameter bar, bottom bars 2 pieces 1 inch diameter bar. At center, top bars 2 pieces 1 inch diameter bar, stiffener bars 2 pieces half inch diameter bar, bottom bars 8 pieces 1 inch diameter bar. Stirrup of 2 legs of grade 60, 3 8-inch diameter bar spacing, 1 at 2 inches, 1 at 4 inches, 1 at 6 inches, rest at 10 inches. Thank you for watching. If you learned something from this video, please like, share, and subscribe to this channel.